Okay, so for this recording we're going to start looking at ellipses. Okay, so one of the things about ellipse is it is an oval shape, but they face in two different kinds of directions. So you could have one where the longer end is at your x-axis, or you could have one where your longer end's on your y-axis. Okay, and you're going to have to make sure that you're able to determine which one is which. If you have one where it's longer at the x-axis, which is called your major axis, your major vertice, gosh dang, is going to have a number first and then a 0, because you're going to the left or to the right. Now, it also has what we call a foci. Now, a foci, I'm going to try to put this in red, if it'll let me draw. It doesn't like it when I try to do the little dots. Try to put one on this side too. Okay, so a foci is going to be, it's going to always line on your major axis, okay? And so our foci would also, in this case, have, a number first and then a 0. We're going to be looking at the foci a lot in determining, if it has a major axis on the x-axis or the y-axis. So if we have one where our major axis is the y-axis, our major vertice is going to have 0 and then a number, and exactly the same thing for the foci. Okay. Okay, and I'm going to try to put foci points in there. Let's see if I can find my pen. It has a stylus, but it doesn't always let me write with one. Let's see. Kind of. There we go. It's the best I can do. Okay, so when you're looking at ellipses, there's two different types of functions, depending on which one you have. And pretty much they look exactly the same. Okay, so x squared, y squared. This is not turning out well. Alright, over 1. And the same thing with one like this. It's going to have x squared plus y squared equals 1. So, there we go. Now, the only major difference between the two is, if you notice they're exactly the same, the major difference is whichever one is your major axis, so like if your major axis is your x-axis, okay, you're going to have your larger number underneath the x, okay, and this is going to be our smaller number. So your larger number is going to be underneath the axis that it is. So if ours was longer on our y-axis, this would be our b squared, because that's our shorter one, over a squared. Okay. So a lot of times with these, what you're going to end up doing is you're going to be kind of looking, you're going to be looking at your foci and trying to determine, which one is your major axis. And if you can kind of remember that, the larger axis, either your x or your y, is going to have the larger number underneath it. So I'm going to just kind of look at some kind of examples that I'm just going to go through and create with this. Okay, so let's say we're focusing just having it overlap on the origin right now at the center. So let's say I have one on there with my major axis on the x, and here's a major axis on the y. Okay. Alright, so with this one, I know that it's going to be x squared plus y squared equals 1. Okay. Now I know that I'm going to have the larger number underneath your x. So let's say if this thing is centered at the origin, and let's say it goes out to 10 this way and 10 this way. Okay. Gosh darn it, it's supposed to be a negative in front of it. There it goes. And let's say it goes up to 4 and down to negative 4 right there. Okay. So we could actually write our equation for this ellipse very, very quickly and easily. Okay. Now my x-axis is my longer axis, okay, my major axis to this, and we go out to 10 in both directions. So technically it's going to be a 10 squared, and then for my y-axis it goes out to 4 in each direction, so 4 squared. So if we wanted to look at the standard equation of this, it would be x squared over 100. Let's try to write 100 under there. plus over 16 equals 1. So that would be our basic standard form of it. Now our foci, I can put this in red, our foci would be somewhere over here, gosh darn it, and over here. It's not working well at all. Sorry, I'm just getting frustrated because it's really hard to talk about ellipses on here. I could do a much better job in person. Okay, so let's say we have one that's on our y-axis. Let's say it goes down to -8 and up to 8 and over to, let's say, 2 and -2. Okay. Again, we could write our function for this pretty easily. If it's centered around the origin, it's just x squared and y squared equals 1. Now our y-axis is our larger one. Okay, so it goes out to 8 in each direction. So underneath our y, it should be 8 squared, or in this case 64. And for our x-axis, we go out to 2 in each direction, so 2 squared, which gives us 4. And that right there would be our formula for our ellipse. Okay, there's a lot of stuff you're going to want to go through and look at on page 867. You want to go through and record a lot of those. I just think sometimes when you look at those, you can see, it just kind of overcomplicates it. So try not to overcomplicate your ellipse formula to it. If it's centered around the origin, it's just x squared and y squared. Don't concern yourself so much with, like memorize. It was always easier for me for your, whichever one's your longest axis, that's where your larger number should be. Okay, and it's just however far out you're going squared. So now let's try to look at a couple examples where we're given some information and we have to try to write our standard form. Alright, so we're going to write the standard form of an ellipse that's going to have vertices at positive, -8, 0, and it's going to have foci at positive, -5, 0. Okay. So remember, the first thing you have to do is you have to figure out if you have a major on your x-axis or your y-axis. Your vertices can tell you as well. However, there's technically co-vertices too, where it crosses your, other axis. So your foci is your better way of determining which one is which. So let's say if I had some sort of an ellipse. Well, my foci is going to go 5 to this direction and 5 to this direction. Okay, there's my foci to it. Well, the foci are on my x-axis, so this means this is an x-axis major. Okay, so x squared, y squared equals 1. I know my longer part's going to be on that axis, so I know it's going to look something like this. Well, it tells me my vertices at 8 and -8. Okay, so my x-axis goes out to 8 in each direction. 8 squared is 64, so that should be underneath my x. Now, here's the thing with this. Now, we know our from our longer one. What we don't know is we don't know our y value to it. So this kind of comes into play with one of your functions that you were given on page 867. It said that you can use c squared equals a squared minus b squared. Okay. Now your c squared deals with your foci. Your a squared and your b squared are these two right here. Okay. Remember, your larger one is your a, your smaller one is your b. Okay. So in this case, we know our c value. We know our foci is a positive or -5. So 5 squared is 25. We know our a squared, that's our larger one right here. Okay, so it's going to be 64 minus our b squared. Well, all this essentially is 64 minus 25, so our b squared is equal to 39. So there is our standard form of our function. Okay. So sometimes they'll go through and give you guys your co-vertices, which would be your b value. Your major vertice is your a value. Your foci is your c value. So we want to be able to, if you have two of those pieces of information, you want to be able to write the standard form of it. Alright, so let's look at another example. So let's say that I have one with vertices at 0 plus or minus 4. And I have a foci at 0, positive, negative, square root of 15. Okay, again, the first thing you have to do is figure out if its longest axis is on your x-axis or your y-axis. Oh, I can't stop yawning. So again, look at your foci, because that's going to tell you, which one you're associated with. Since it's 0 and then a number, we had to go over nothing and then up and down. So that means that my foci are actually going to be on the y-axis. So this is a y-axis one. Remember, the only difference is underneath your y in this formula, you're going to have the larger number. So my vertices for this one on my y are going up to 4 and then down to negative 4. Okay, so it goes out to 4 in each direction, so that should be 16. Okay, or 4 squared. Oh, sorry, equals 1. Now we have to find that b squared again. So, again, our c squared equals our a squared minus our b squared. Well, here's the thing. This was, again, our c value. I should have wrote c first, I guess. But our c value is the square root of 15. Well, the square root of 15 squared is 15. Our a squared is 16. So essentially this is 16 minus 15, so our b squared is equal to 1. So that means there's my standard form of it. So I know the book kind of, probably for the most part, kind of overcomplicates it. Please don't let it do that to you. It's not too terribly complicated, especially if it's centered at the origin. So let's look at ones that are not centered at the origin. I'm supposed to say not centered. I think I'm going to give up with writing. Okay, so not centered at the origin. Okay, so a lot of this information is on page 869, so you're going to want to go through and get that stuff written out. Okay. So essentially, basically what you're going to have now is you're now going to have an ellipse that has a major with your x-axis, which just means it's longer on the x-axis version, but it's not going to be centered at the origin. So it could be over here, or one that's centered on your y-axis, or majored at your y-axis, would look something like that. The formula is very similar. For this one, it's x minus h squared over your a squared. Remember, a is still your longer one, so x squared, plus y minus k squared over a b squared equals 1. Okay. Now, hk is your center. Okay. So notice that it is the opposite sign, of what you see in the parentheses when you go through and find your center. It's going to be important to find your center because you know how we were finding like our a squared and things like that? It was always how far off we went each direction. Basically, instead of being 0, 0, you're going to start at your center and you're going to figure out how many spaces to the right or to the left or up or down are you going to be going, okay, to be able to find those links to it. Okay. This one with your y-axis is basically the same kind of thing. It's the only thing, gosh darn it, the only thing different is your a, or whichever one's the largest, is going to be with your y. Gosh darn it, I cannot. A squared, and this whole thing's equal to 1. So I completely ran out of room. So what we're going to do is we're going to go through and kind of look at, kind of one of these examples. Unfortunately, it's going to be very, very hard for me to do it on here. I'm really the best at it. Okay, so let's say we want to write the standard form of an ellipse that has vertices. There it goes. Let's say it has vertices at -2, -8, and negative 2, 2. Here it goes. And let's say it has foci at negative 2, 7 and negative 2, 1. Okay. So, like I said, you're going to want to go through and look at your foci to kind of tell you which one it's going to be. So I'm going to kind of work with that in the middle first, and then I have to erase it so I have space. Okay, so with this one, if I think of a standard graph, my foci is at negative 2, 7, so I'm going negative 2 to the left and then up 7, so I'm up here, and negative 2, 1. So remember, your foci is always right on your major axis, so this is going to be a y-axis. So when I do this, I know that I'm going to have to write my larger number underneath my y-axis to it. Okay. So I'm going to erase that off. That's one of the major things we had to go through and figure out first. So I'm going to put kind of our basic standard equation, on this page as we go through, and then we'll add to it a little bit at a time. Okay, so the first step is we got to go through and find your center. Okay, now our center is going to be right smack dab in the middle of our vertices. Okay, so this is where you're going to go back to Math 1 and have to go through and do midpoint. Okay, so we had to find the exact middle of those 2 points. Okay, well, if I look at the x's, the exact middle between negative 2 and negative 2 is negative 2. The exact middle between negative 8 and 2, in this particular case, is going to be at negative 3. Okay. So if you remember from Math 1, to find your midpoint or your center, you add the x's and divide by 2, and you add the y's and divide by 2. Okay? Or you can just go through and kind of figure out exactly where the middle would be. Either way, there's my center. So now, I can at least go through and write that first part of it. Okay, I'm going to write it kind of here at the bottom. So, remember it's opposite signs, so plus 2, because that's my x value, squared, plus, now y plus 3 squared equals 1. Kind of ran out of room anyway. Either way, but, I have that part of it already. Okay. Now, what I'm going to have to go through and do is I have to go through and find, particularly my a squared. So, to find my a squared, I have to go one of those formulas that I have on page 862. It said that your 2a is the actual length of that major axis of it. So 2a is basically going to be the difference between this right here. So between 2 and negative 8. Okay, start from your larger one minus your smaller one. Okay. So we get 2a is equal to 10. So a has to be 5. So what that tells me, since my a is 5, that means my a squared is 25. Okay, and remember this came from my major axis, so that 25 is going to have to go underneath the y. What is a 2? Sorry. Sorry, my kids came out again. Okay, so we found our a squared. Now, the only other piece of information we have is our c, which is our foci. So, we're going to have to use that. Okay, this is, well, that's step 3, so just erase step 2. We're going to have to go through and find our c squared. Okay. Now, from our formula to it, it has, if we look at page 869, it's got this for our foci. Okay. We really only need this part of it. Okay. And what it's going to do is you're going to have your k plus c, and then your k minus c. It actually does not matter which one you use. I generally just use the positive one, but I'm going to put both of them on here so you can see what they're equal to. Basically, if we look back up here at the foci, the negative 2 is your h value. We already have that. We don't need that. What we need to do is find this one right here. So your k plus your c and your k minus your c is going to equal the 7 and the 1. Okay? Your higher number goes with the plus, your lower number goes with your minus. Okay? Now you actually already have your k, because remember when you go through and find your center, that is your h and your k. So we already have our k value when we're going through and finding this. So our k value in this one is -3 plus c equals 7. And if we just go through and solve, we get c is equal to 4. If we had done the same thing with this one, okay, if we minus 3 to both sides and then go through and change the sign, we would also get that c is equal to 4. Okay? So either way that you go, you're still going to go through and get the same answer. Okay? So like I said, it doesn't matter which one you use. Okay? But what they're going to do is they're going to equal the y values of the foci. Well, now we have our c value, so our c squared is going to be 16. So now we can use that formula that we had a little while ago. I'll get rid of these. Okay, our c squared, our c squared is equal to our a squared minus our b squared. Well, our c squared is 16, our a squared is 25, and essentially this is 25 minus 16, so your b squared is equal to 9. And now we have all the information we need to be able to write our standard form. Okay, so these get to be a little bit more complicated because you have to figure out the center of it, which gives you your h and your k, and then you have to go through and for your a values, 2a equals the subtraction of your 2y values. You know, that'll give you a squared. Then you can go through and find your c squared, and then once you have those two, you can find your b squared. So I'm going to erase this very sloppy answer over here. Alright, so to write our standard form, again, it's going to be x and an opposite sign of our h, so plus 2 squared, and then our y value, y plus 3 squared. All this is equal to 1. Alright, now again, you know, our a squared is our larger one. That's going to go to our y because we figured this is a y-axis one, so we're going to have our 25. And our b squared is our smaller one, which in this case is 9. Okay. So hopefully that helps a little bit. Alright, now we're going to look at graphing these. Graphing these are a little bit on the easier side, especially if you kind of look at how we talked about these at the beginning. So let's say I had x squared over 9 plus y squared over 25. Okay, equals 1. Alright, so this one is centered at the origin. It doesn't have an h or a k or anything added subtracted from my x or my y. So the nice thing is on my y-axis, we're going to be going out to 5 in each direction because 5 squared gives us 25. So it's going to go up to 5 and down to -5. Our x is going to go out to 3 and -3. So there is our ellipse. Well, that's terrible, but either way, it's elongated on our y-axis. So if we want to go through and be able to find the foci to this, again, your c squared is equal to your a squared minus your b squared. Well, we know our larger one is our a, and our smaller one is our b. So c squared is equal to, in this case, 25 minus 9. So our c squared is equal to 16, so that means our c is equal to 4. So it's going to go up to 4 and down to -4, and there are our foci. Okay, so don't make those, you know, overly complicated as you go through. Sometimes your c's are not going to come out to perfect numbers. It may come out to a radical that you may have to go through and reduce. Okay, we also have to look at being able to get these things into standard form. So let's say I have 4x squared plus 25y squared equals 100. Okay. Well, the first thing that you want to do is you want to get this thing and you want to set it equal to 0. Or, sorry, equal to 1. So if we set it equal to 1, we basically have to divide everything by 100. So what that's going to give me, if I simplify, 4 over 100 equals 1 over 25. 25 over 100 is 4. And there's our standard form. Okay. Now we could go through and graph it. At this point we could go through and find, it just kind of depends on what you're trying to do. Larger numbers underneath my x, so this is definitely going to look, like that. And it's going to go up to 5 and negative 5. For my y value, it's going to go up to 2 and to negative 2. And again, if I wanted to go through and find the foci to this one, it's c squared is equal to my a squared minus my b squared. So my c squared is 25 minus 4. So c squared equals 21. So c is the square root of 21. Okay, so this is kind of one where it's not coming out to nice numbers. Your foci would be at, square root of 21, 0, negative square root of 21, 0. Okay, so start getting to ones that are graphically not centered at the edges. Okay, so let's say if we try this one, x plus 2 squared over 4, and then y minus 5 squared over 9. Okay, automatically, this one's larger, so it's a y-axis problem. Okay, all right. So what I'm going to go through and do first is I'm going to try to go through and graph what I can. You need to know where your center is. So our center for this one is, remember, opposite signs of those right there. So it'd be negative 2, 5. Okay. So when I graph this thing, and this thing's going to be terrible, sorry. We have to go to negative 2 and then 1, 2, 3, 4, 5. Oh, it's going to be a terrible graph. Let me change the background of this one real quick. I'm going to get rid of this. See if this will help. Let's try that. See how well that can work. See if I can draw decently or not. That sucks. Okay. Let's see. No. About the best that I can do. Oh, that's terrible. Okay. See, I hate doing this on here. I can't draw a straight line. Either way, okay, so let's say our center's at negative 2, 1, 2, 3, 4, 5. Let's see, negative 2, 1, 2, 3. Dang it, that's at 4. Hold on. 2, 1, 2, 3, 4, 5. I think I did that right this time. Negative 2, 1, 2, 3, 4, 5. Yes, okay. So there's my center to it. Okay. Alright. Now, here's the thing. I know that I'm going to have to go, basically since, let's say if I look at this one, okay, I have to go, not 9 spaces, but I have to go into what squared spaces. So I'm going to have to go 3 above that and 3 below that. So 1, 2, 3. Oh gosh. It's not as best as I'm going to do. And 1, 2, 3. Okay. And now I need to go over 2 spaces for this. So it's going to be right here on the axis, kind of, and then to that direction. Okay. So there is my ellipse to it. I'm going to try to carefully write out my ordered pairs. This one will be at 0, 5. This one, negative 4, 5. And this one up here would be at negative 2h. And then this one down here would be at negative 2, 2. Yeah, sorry, I can't write really small with this. Okay, but either way, once you go through and find your center, you're just going to use those bottom numbers to go through in each direction. Now, if you wanted to find where your foci was, again, c squared equals a squared minus b squared. So 9 minus 4, so my c squared is 5, which means my c is going to be plus or minus the square root of 5. So basically my foci is going to be square root of 5 above the center and square root of 5 below my center. Okay. So, as we start going through and looking at these, we want to be able to write, our points to it. Again, if you look at that previous page, I'm going to try to write the ordered pair for my foci. Okay. So, what I'm going to end up having to do, if I want to write the ordered pairs for my foci, well, I definitely had to go over -2 and -2. Well, like I said, I have to go basically from my center, which in this case is 5, okay, because we're looking at the y value. So it's going to be 5 plus the square root of 5 and 5 minus the square root of 5. Okay, if I wanted to go through and write those ordered pairs. So just kind of be careful. Ones that are not centered at your origin, make sure you find your center. Go off in each direction. Graph paper would be easier as you go through and try to find these. Yeah, and then use your formula, your c squared equals a squared minus b squared. And just remember your formula for writing out your foci. Alright, so we're going to go through and look at one that is not in standard form and show you how to put it in standard form. We're not going to go through and graph it at this point. Okay, so I'm going to get rid of this background and go back to this. Alright, so let's say I had 4x squared plus 9y squared minus 40x plus 36y plus 100 equals 0. And I want to get this ellipse in standard form. Okay. Now, if you remember in Math 3, basically completing the square, when you were doing circle equations, that's essentially what you're doing. So you want to put your x's together. Okay. So we're going to put 4x squared minus 40x together, and then we're going to put the y's together. So 9y squared plus 36y, and we've got to move the constant to the other side. Okay, so that's step 1. Get the x's together, get the y's together, move the constant over. Now, what we have to do is we have to pull out a greatest common factor, if you have one. Sometimes you do, sometimes you don't. So this first group I can definitely pull out a 4. It's going to be x squared minus 10x. Okay. And we've got to pull out a greatest common factor here, which would definitely be 9. So y squared plus 4y equals negative 100. Now comes into the part from back in Math 3. So we're going to leave the 4, and we basically have to make this a trinomial. So x squared minus 10x plus a space. I always have to leave a space. And now this one, y squared plus 4y plus space equals negative 100. Now, in order to figure out what needs to go in this space, what you do is you want to take, and I'm going to put this in a different color, you want to take this number divided by 2 and square it and put that in that space. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. Okay? Now, here's the thing. Back in Math 3, you would, if you added the 25 on the left, you had to add 25 on the right, but you have this on the outside. So basically, your other side of the equals, you have to do 4 times 25, which is 100, and you have to add that to the other side. We're going to do the same thing with our y's. We're going to take this number, divide it by 2, and square it, and put that in the space. So 4 divided by 2 is 2. 2 squared is 4. Okay. Now, we have to, for the other side, we have to do 9 times that. So 9 times 4 is adding 36 onto this side. Okay. So now, this will factor nicely. So I'm going to put this back into black. So I have 4. This factors down to, x minus 5 squared. Basically factors down to x minus 5 and x minus 5. This one will factor down to y plus 2 and y plus 2, so y plus 2 squared. And we add up everything on the other side, and we end up getting 36. Now we can go back and do what we did on that problem a few problems ago. We're going to divide both sides by the 36 because ellipses are always equal to 1. So we're going to go through and divide by 36. Okay. So now we just have to simplify each one of these. So this one, 4 over 36, is basically 1 over 9, so it becomes x minus 5 squared over 9 plus 9 over 36 is basically 1/4. So it becomes y plus 2 squared over 4 equals 1. And there's your standard form of your ellipse. And from that, you're going to have to do that a few times for your in your homework, okay, as you guys go through. Again, I've sent out a couple emails for you guys to let me know. It's probably not a bad idea for us to set up a Zoom session where we can all get together and we can go over any homework questions that you have, okay, as you go through. Just kind of looking at your homework to it, the very first problem you're going to kind of have to do this. You're going to have to get it in a standard form. You know, a lot of them you're just going to be finding your endpoints, your vertices, your coordinates, you know, that sort of thing, and graphing. So hopefully it's not too bad and that this video helped, even though it was very sloppy.